Question number 24. The equation of a curve is y is equals to x cubed plus x squared minus x minus 1. Part A. Determine the stationary points of the curve. So to find the stationary points of the curve, whose equation is y is equals to x cubed this is x cubed plus x squared minus x minus 1. We have to get the dy dx. We differentiate. Dy dx will be equal to 3x squared plus 2x minus 1. And at the stationary points, dy dx of this curve should be equal to 0. So we have 3x squared plus 2x minus 1 being equal to 0. The product here is negative 3. The sum is positive 2. So the factors are 3 and negative 1. So we solve for the value of x, that is 3x squared plus 3x minus x minus 1 is equals to 0. So 3x into x plus 1 minus 1 into x plus 1 is equals to 0. So we have 3x minus 1 into x plus 1, which is equal to 0. Either 3x minus 1 is equals to 0, and the value of x will be 3x will be 1 divided by 3 divided by 3. So the value of x will be equal to 1 over 3. Or x plus 1 is equals to 0, and the value of x will be equal to negative 1. Now these are the x coordinates of the stationary points. So we have to get the y coordinates for those stationary points by substituting the values of x on the original equation. So we have y, when x is negative 1, y will be equal to negative 1 cubed plus negative 1 squared minus negative 1 minus 1. So negative 1 cubed is negative 1 plus negative 1 squared is positive 1. Then we have negative negative, so it's positive 1, and then minus 1, and this is 0. So one of the stationary points is negative 1 and 0. Now we get the other y coordinate when the value of x is a third. So we have y is equals to 1 over 3 cubed plus 1 over 3 squared minus 1 over 3, then minus 1. So we have 1 over 27 plus 1 over 9 minus 1 over 3 minus 1. 1 over 27 plus we have 1 over 9 minus 1 over 3. This one is squared, so we go to, now we have minus 1. So we can check, we have 1 over 27 plus 1 over 9 minus 1 over 3 minus 1. Yes, that's how our expression is. Now we find the LCM of 27, 9 and 3, and it is 27. So 27 divided by 27 is 1, multiplied by 1 is 1, plus 27 divided by 9, which is 3, multiplied by 1 to give us 3, minus 27 divided by 3, which is 9, multiplied by 1 gives us 9, minus 27 divided by 1, which is 27, times 1, which is 27. So this will be 4 minus 36 over 27, which is negative 32 over 27, can be written as negative 5 over 27. So the other stationary point is a third, comma, negative 5 over 27. Roman 2, we are told to determine the nature of the stationary points in A above. And for us to determine the nature, we have to find the second differential of the expression. So we go to dy dx second time will give us 6x plus 2. This is the expression we are differentiating the second time. And now we substitute for the values of x. And the values of x, we are told they are a third and the other one is negative 1. So I start with negative 1. At x is equals to negative 1, we'll have 6 multiplied by negative 1, which is negative 6, plus 2 to give us negative 4. And since this is negative, then it means that this is the maximum point. Note that when x is negative, when the second differential of the expression is negative, then that point is a maximum point. Now we can check when the value of x is equals to a third. The second differential of the expression will be 6 multiplied by a third plus 2. So 6 multiplied by a third is 2, plus 2 gives us a positive 4. And since the second differential at this point is a positive, then it means that this point is the minimum point. Minimum. Now we go to part B, Roman 1, where we have been told to determine the equation of the tangent to the curve at x is equals to negative 1. So we have to get the gradient of the curve, and the gradient of the curve is given by dy dx, which is 3x squared plus 2x minus 1. Now we replace the value, or we substitute the value of x as x is equals to 1. So we'll have 3 into 1 squared plus 2 into 1 minus 1. So this is 5 minus 1, which is equal to 4. Now this gradient of the curve is equal to the gradient of the tangent. So the gradient of the curve is equal to the gradient of the tangent. at that point. So now that we have the gradient of the tangent is 4 and x, y as a general point, another point will be when x is 1, and when x is 1, y will be 0. You replace to the original equation, which is this one. You replace 1 here, you have 1 cubed plus 1 squared minus 1 minus 1, and that will give you 0. So now our equation will be y minus 0 divided by x minus 1 is equals to 4. We cross multiply, we have y is equals to 4 multiplied by x minus 1. So y is equals to 4x minus 4. That is the equation of the tangent. Now we are told to find the equation of the normal to the curve at x is equals to 1. Here you are supposed to note that the curve and the normal are perpendicular to each other. So if we take the gradient of the curve, we multiply by the gradient of the normal to the curve, we should get -1, meaning that the gradient of the normal to the curve is negative reciprocal of the gradient to the curve. So the gradient of the curve is 4, and therefore the gradient of the normal to the curve is -1/4. We have a general point xy and a point which is 1, 0. Now y minus 0 over x minus 1 is equals to -1/4. So we cross multiply, we will have 4y is equals to -1 into x minus 1. So 4y is equals to -x plus 1. We divide by 4, we divide by 4, and y is equals to -1/4 x plus 1/4. This one is also divided by 4.